Hey Math 8, today we are going to work on using the Pythagorean Theorem, okay? So this is 5.6. Last class we did 5.5, which was actually we just learned the Pythagorean Theorem. But today we're going to work on how we can use the Pythagorean Theorem on real-world problems and real-world situations. So that's kind of what we're looking at today. Just as a quick reminder, the Pythagorean Theorem is a squared plus b squared equals c squared. Okay, as well as that, we have the facts that a and b are legs, okay, and c is always the hypotenuse, okay, sometimes called the hippopotamus. Okay, so that's pretty much all you need to know as far as background knowledge from the last lesson. If you missed it, it would be good to go back and look at that video lesson so that you can understand how we actually use these. But if you were there, this should be enough to sort of refresh you on what we did last class. So if we go ahead and go into some example problems, if you're wondering, this is page 424 in your book. All right, so example 1, we have this problem. It says write an equation that can be used to find the length of the ladder, then solve and round to the nearest hundredth. Okay, so if I look at this, we've got our building here. We can see that we have, and I'll go in green here, the corner of the building is right here, okay, and the distance from the corner of the building to the base of the ladder, or the bottom of the ladder, is 8.75 feet. Okay, and then from the corner of the building to the point on the building that the ladder reaches is 18 feet. And what we're trying to figure out is, in order for us to reach 18 feet up the building, how long does this ladder need to be? And that's our x there. Okay, so this is a real world situation. I actually found myself in a situation very similar to this when I was putting up Christmas lights this past winter. So it is something that you need to know how to do, believe it or not. So if we have this problem, I'm going to set it up using the Pythagorean Theorem as a squared. Sorry, let me change the size on this pen because it's a little bit big. All right, a squared plus b squared equals c squared. Okay, now a reminder, c is the hypotenuse, which means it's the longest side. It's also the side that is across from or opposite the right angle. The right angle we can see is right down here, which means the opposite side would be x. Okay, so that tells me I don't know what c is. Okay, so I'm just going to rewrite c. And then a and b, I know are the legs, the two sides that are attached to the right angle. So that would be this side, which is 18 feet. So I'm going to plug in 18 for a. And then this side, the 8.75, I'm going to plug in for b and square that as well. All right, from here, I can go ahead and solve for c squared. All right, so 18 squared, I'm going to put into my calculator because I don't know what that is. So 18 times 18, or 18 squared, is 324. And then same thing for 8.75. I don't know what that one is squared either. So I am going to square that in my calculator, and I'm going to get 76.5625. All right. And I'll go ahead and write out that whole thing because why not, right? Okay, at this point, I can add these numbers together. I know that 324 plus 76 is 400. Okay, it just works out that way. I'm going to rewrite those because I had ink to shape on, so it just looks funny. All right, so we have 400, and then I can just add the rest of this decimal to it. Okay, so all I did there is I just added these two numbers together, and I know that is what c squared is. Now I need to get c by itself. So if you remember, the last step in order to get c by itself is to find the square root of c squared and find the square root of 400.5625. And that is going to give me that c is approximately, okay, this means approximately 20. All right. Since this is a word problem, a real world problem, I am going to want to rewrite that into my units. So that would be 20 feet. All right, so what this tells me is that in order to reach 18 feet up the building, I need a 20-foot ladder. All right, really simple. Kind of the long way of getting there, but also the best way of getting there to make sure you don't have a mistake. Okay, so that's the first example. We'll go ahead and jump into another one. All right, so example 2, we're on the same page. I think this is 424 is what I said. Yeah, page 424. We have write an equation that can be used to find the height of the plane, then solve and round to the nearest tenth. So this triangle, they're showing us we have one plane up here, one plane down here. The distance between them from left to right or across the ground would be 10 miles. And the diagonal distance, for some reason, we know that that is 12 miles. So we want to find the exact height of this plane right here. All right, we can use the Pythagorean Theorem to do that. Okay, so I'm going to set it up again. A squared equals C squared. All right, again, I know my hypotenuse is C, and that's also the longest side, the side across from the right angle. In this case, that would be 12. So I'm going to put 12 here in place of C. And then A and B are my legs. It doesn't matter which one is which. This one's already labeled B though, so I'm going to leave B as it is since that's clearly the one we don't yet know. And then A would be 10, right? And just plugged this number in for A. Okay, so I've got my setup done. Now I just need to simplify the what I can. So 10 squared is 100. That's one of the ones we memorized, so we should all know that one. B squared, obviously I don't know what B squared is just yet, so I'm going to leave it as is. And then 12 squared is another one we should know. That is 144. All right, from here I need to solve for B squared. So I'm going to subtract 100 from both sides of the equation. And that is going to give me B squared equals 44. All right, now there are two ways that we can go. Okay, the first way, well, at this point, there's really one way to start. I need to get B by itself, so I'm going to use the square root to cancel out that. So now I have B equals the square root of 44. At this point, there are two ways I can go. The first way is I can estimate, all right, and I can type that into my calculator and see what the square root of 44 is. And I get 6.63. All right, so about 6.63. I rounded there. I can also, though, use my methods of simplifying radicals that we talked about in class a few days ago. And I can go ahead and find the square root of 44 as a simplified radical. So what I'm going to notice is that I know 11 times 4 equals 44, right? 11 and 4 are both factors of 44. So I'm going to write out the square root of 4 times the square root of 11. And then I know the square root of 4 is a perfect square, or 4 is a perfect square. So the square root of 4 is going to be a whole number, and that's going to be 2. And now I'm going to rewrite the other square root. Okay, so just a refresher of what that looks like when we simplify radicals. So that gives us our other answer, and that one is not an approximation. That is an exact answer, although it's not entirely clear what that means, most likely, right? That said, sometimes it might ask you, a question might ask you for this answer. Sometimes it might ask you for this answer. It's important that you know how to find both, okay? That is it for that problem. What I want you to do now is I want you to go ahead and try out this got it problem A right here on your own. This is a good problem as well. So give it a try, and then after that, we will move on. All right, so actually, once you have finished this got it problem, that is going to be it for this video. The answer that you should get here for the length of the new banister, go ahead and try it on your own. I want you to make sure that you know how to get the work and everything, but the answer you should get is 13 feet. It's nice and exact, so that's kind of a little bit lucky for us there. But you should get 13 feet. If you don't, try it again. See if you can get it. All right, and then after that, we are done for this video. So pretty quick, not too much, just the one got it problem. So if you have any questions, please feel free to come ask me. Other than that, that's it. I will see you guys in class.